All right, so you can see here I have trained my model and I have achieved a accuracy of 95% compared to the accuracy previously that was, I think, let me just quickly check that. It was around 85%. So, and this was after 20 epochs. And in this case, I've achieved this accuracy in just 10 epochs. And you can see it is getting stabilized, after epoch number 6 itself. So, basically, our model, that is AlexNet model, the pre-trained model, it has done quite a better job. Now, what I'm going to do here is, lastly, is I'm going to run this on a new image. So I'll say run a new image from, or should I say through the model. Okay, so um, I know that I have about 6,000 images in my test set. If I just quickly check that. So test data, it is 6251. So I can choose any number from 0 to 6250. Why? Because those are going to be the index number. So I'm storing that index number I as, again, just any random number. And I'll say that I'm choosing a random number of a random index of 12026. Now I'll say that I'll take that image and do the inverse normalization. Remember, we have already normalized our image. So to inverse normalize that, I'll say the test data and choose that particular index. And I don't want the label, I just want the array, right? So I'll get that. And if you do that, this is the inverse normalization. This is not X, this I. There you go. And I'll assign this to image. Why again? Because I want to take this and show you the image itself. So I'll say plt.imshow and pass in the np dot transpose. And I'll say im.numpy, because again, your matplotlib only plots the numpy library 1 to 0. That is the order. And I'll say plt dot show. There we go. So this is apparently the image that we have. You can take any other number. For maybe I'll take 19 or just any other number, doesn't matter. You can feel free to experiment with this and just try out different things here. So these are the images that you have. All right. Anyway, the thing is, so if I just check the shape of this, I'll say test data, that particular index, again, whichever I'm choosing. And I just want to grab the array and not the label and check the shape of this. You can see it is 3 by 224 by 224. So it has been taken care of. Now what I can do is I'll try to make the prediction using the custom CNN model that you have designed previously. So I'll say this is the prediction. And here I'll say that um, first of all, I'll take the model and put this back to the evaluation mode. Model dot evaluation, and I'll say with torch dot no eval. Uh, Never mind. This is no grad. All right. Then I'll say take the CNN model that you have and pass in the test data, that particular index number, and 0. Then dot view as 1 by 3 by 224 224. And I'll say get me the argmax of this. And lastly, I'll say take the prediction and I'll say that f literal, the predicted class, would be new, and I'll assign this to something. I'll say this is, let us say pred only, right? And I'll remove this new here. So I'll say pred dot item here, and then I'll say the class underscore names, if I remember correctly. Uh, this is the class names that I have to actually find out whether it is cat or dog. Uh, yeah, it is class names only. Right, you can see it's a class name, so you can just take this and paste here. I hope there is no spelling mistake. So we have this. All right, then I'll say that this is pred dot item here, and let me fix some more things here. This should be a curly braces. Let us run this. There you go. So apparently my model thinks that it is a dog. Remember, my model, this one, the custom model, it has 86% of the accuracy. So it is expected that if you are getting this, but let us now try this on the AlexNet model. So I'll copy this, paste here, just make some changes that this is AlexNet model. Here also, this is AlexNet. And here, this one as well, AlexNet. All right, let us run this now. Okay, I've got a error here because it is not model, it is just AlexNet. There you go. So you can see that this particular model, it is doing a much better job. What you can also do is you can also download some image or a sample dog or cat image from Google. For example, I'll say that I want images of dogs, let us say, and I'll just take any image here from, for example, this one by Pixabay. So if I just open this, there we go. It looks like a good image. It's a JPG file. That's a good name. So I'll just download this and I'll just, write this a very simple name rather than this kind of, very complex name, which is kind of, auto-generated. Instead of that, I'll just put that as a very simple name. I'll say it's a puppy. All right. And I have to make sure that I put that image in the same folder where I'm running this notebook. Okay, so I've downloaded this and put that in the same folder where I'm running this notebook. You can see it has been created just 30 seconds ago, and you have this a JPG file. Now what I have to do is I'll say equal to, let us say, image dot open and pass in the name of that file, that is puppy.jpg. Before I run that, you also have to do few things. That is, you will copy this entire thing here and make some changes. That is just to make things easy for you. I'm taking this test data and I'm inverse normalizing it, but you can only inverse normalize it when you have normalized it. So first what I'm going to do is I'm going to say dog underscore normalized, and for that, if you remember, we have created this instance of test normalization somewhere here. There you go. Sorry, test transformation. And you can see that I'll just put that the same thing here and just pass in the dog. Remember, dog is this image, the newly developed, newly downloaded image, and I'm doing the normalization first and then inverse normalization. Why we are doing that? First, because we have to feed this model to, feed this image to our model, and also, I have to do inverse normalization just to display you the image. So if I run that, I'm sorry. This is, yeah, we have to remove this as well. This is no longer this test data. It is dog normalization. There we go. So the same image that we have gotten here. One more thing that you can see here, that if I just take the image and run the shape, it is now in the same shape as my which my model is expecting. So I'll again take, for example, this model here, right, AlexNet, and I'll pass in this image. So once you pass in this here, I'll have to change the this thing, which is dog, or should I say I am, simply, right? So if you run that, there it goes. Now it is predicting this dog here. Let us take one more example on this. I'll just, download one more image. And for that, I'll go for, this time I'll go for the cats. I'll take, uh, let us say, how about this image, if it is available. I'll just put that as cat. Yeah, it's a JPG image you can see here. So I'll take this image now and do a copy paste one more time. I'll copy this, paste here, right? And so just put, cat everywhere instead of dog, and hopefully I'll get the same result. All right. So there's the cat image here. And again, you can take the AlexNet model in this case and just run this as it is. There you go. So my model has predicted the zero class, that is cat class. All right. So you can see here that we, in this case, in this particular video, or should I say series of videos, we have designed the CNN architecture from the scratch, and we have gotten to a very, effective CNN model that is being able to predict the cat versus dog image. With that, it's a wrap for this particular playlist. I'll meet you in the next one. Thank you and goodbye.